video, we are going to talk about set in Python. Like list, set is also a collection of items. And like list, you can have items of same type, like all integers, or you can have items of mixed type as well. For example, some integers and some strings. The differences from list are set contains only distinct items, which means no two items in a set can be same. If you have a set which has items 10, 20, 30, and if you try to insert any of these items again, it would not insert that. It will only keep distinct items. If you try to insert 40, that would be inserted. The second difference is set is unordered, which means if you insert certain items in the set and if you try to traverse the set or try to print the set, the order in which you are going to get the items is not predefined. For example, if I insert 10, 20, 30 into a set and then I traverse through the set or I print the set, I may get the output as 10, 20, 30 or 20, 10, 30 or 30, 20, 10, any of these 6 permutations of these 3 numbers. So there is no predefined order among the elements of set when you traverse the set or when you print the set. The third difference is no indexing. List is basically an array, and in arrays you can use indexing. You have a list, say, of items, 3 items, 10, 20, 30. You can get the item, say you have a list L, you can get this item by using L0, you can get this item by using L1 and get this item using L2. But if you have a set of items, you can't use indexing because there is no ordering. Indexing is also not allowed on sets. Now these are the problems with set. These are the features of list which are not there in set. Then why do we have another collection? We have list which does not have these restrictions. The reasons are there are certain operations which are really fast on sets. For example, if you have 2 sets and if you want to find out union of 2 sets, it's really fast to do the union of 2 sets, really fast to find the intersection of 2 sets, really fast to find the difference, symmetric difference and other set operations. If you store certain items into lists and then you try to find out their union, intersection, difference, etc., those operations are going to be slow. But if you store these items into set container, then you are going to get these operations done fast. The reason for fastness of these operations is set internally uses hashing. When you store items using hashing, you can quickly do search, insert and delete operations. Let us see how search, insert and delete operations can help you in finding these operations. For example, if you are doing intersection of 2 sets and if first set contains 10, 20, 30 and second set contains 30, 10, 40, how will you find intersection? You will traverse through the items of first set and for every item you will check if it is present in the second set also or not. If it is present in the second set, then it's part of the intersection. So if you have used hashing, then searching for an item is going to be really fast. So you will search 10 in the set, you will find it and you will say it's part of the intersection. So you did a search operation or membership test operation, and membership test operation or search operation with hashing is really fast. So you can quickly find out if 10 is present in the set or not. Then you can quickly find out if 20 is also present. You can quickly find out if 30 is also present or not. So these searching operations are really fast with hashing. That's why operations like intersection, union and difference are also fast. Here is our first Python program on set. We have created set S1 with values 10, 20, 30. Please note that I have used curly braces here. When you create a list, you use square brackets. When you create a tuple, you use normal small brackets. But for set, we use curly braces. After creating the set, I have printed the set. When I print the set, I get these values 10, 20, 30. But please note that the order in which you get this output is not predefined. You may get the items in different order as well, like 30, 20, 10 or 20, 10, 30. Here is another set S2, which is created using a list. I use a set constructor here, and with set constructor, I provide a list. It's a square bracket, right? So it's a list. So I provided a list with 10, 20, 30, 40 values. So it creates a set with the values from the list. In this constructor way of creating a set, you can provide another set as well. You can provide a tuple as well. So whatever you provide, it takes the items of that collection and creates a set for you. So here I have provided a list with values 20, 30, 40. And when I ran this code, I got the output as 40, 20, 30. You will notice that this order is different from this order. Right, this is 20, 30, 40, and the order that I got is 40, 20, and 30. Now this is interesting. When you create a variable with a pair of curly braces, and if your intention is to create an empty set, it does not create an empty set. It creates an empty dictionary, because curly braces are used for both set and dictionary. When I printed the type of S3, I got the type as dictionary. If you want to create an empty set, you need to use the constructor style. You need to use set and then empty brackets. This creates an empty set. When I printed the type of S4, I got the output as set. Now when you print an empty set, it again does not print empty curly braces like this. It prints something like this, set and then empty normal brackets. Here is our second example program to show insertions in a set. We have created a set with values 10 and 20. We have used curly brackets here. Then we have added 30. And then we have printed set. So we get the output as 10, 20, 30. Now we have tried to add 30 again. And as we said earlier, set contains only distinct items. So when you try to add 30, nothing changes in the set. And then you print the set again, you get 10, 20, 30 again as output. Now we have update function. Using update function, we can add items from other collections. For example, we have added an item from list. We have passed a list with two values 40 and 50. How do we say it is list? Because we have square brackets here. So we have added 40 and 50 to the set, and now set contains 10, 20, 30, 40, 50. But please note that the order in which we are getting the items is unpredictable. We are getting 40 first, then 10, then 50, then 20, then 30. Now, so this is printed by this print statement. We get this output after adding the 40 and 50. And after that, we have again called update. And this is to show that you can add multiple collection items to a set. So I have added items from a set. These are curly brackets. And I have also added items from another list. So all these items are added to the set. So now set contains 10, 20, 30, 40, 50, 60, 70 and 80, 90 as well. Now if I print the set, I get all the items, but again I can't predict the order in which I am going to get the items. Here is our next Python program to demonstrate removal operations on set. So we have a set with values 10, 30, 20, 40. The first function we are using is discard. If you provide an item to the discard and if the item is present in the set, it is removed. So we have provided 30, 30 is removed and our set now has 3 elements 10, 20, 40. And if we print the set, we get these 3 items. Please note that we can't predict the order. We can get items in any order. The one thing about discard function is if you provide an item which is not present in the set, then it's not going to do anything. For example, if I provide 50 here, it would not change anything to the set and our set would remain as it is. The next removal function is remove. It works like discard. If you provide an item, it's going to remove it. After we call remove 20, we are going to have only 40 and 10 left in the set, and if we print the set, we are going to get 40 and 10 as an output. Now what is the difference between discard and remove? As we discussed earlier, discard function does not do anything if you provide an item which is not present in the set. But remove function raises an error. If you provide an item like 50 here, which is not present in the set, then it's going to raise an error. And if you provide an item which is present, then it's going to work like discard. It's simply going to remove the item. So if you want to be careful about the items and if you want to remove only those items, then you can use remove with membership test function. Like if an item is present in the set using in operator, like you can say X in set, then only remove X. Otherwise don't remove X. So if you want to call remove, it's better to check for membership first to avoid those errors raised. If item is a member, then remove it. Otherwise probably show a text error message to the user that the item that you are trying to remove is not there in the set. Discard function will work silently. It won't cause any disturbance if an item is not present, but remove will raise an error. Stop your program and raise an error. Now after removal, if we print set, we are getting this item. So this print is printing this item, this set, and this print is printing this set. Now we have one more function, clear, and clear is there with list as well. Once you call clear, everything is removed from the collection. In this set, everything will be removed and you will have an empty set. I have printed set after this and we get an empty set. As we have discussed, when you print an empty set, you don't get pair of curly braces, because pair of curly braces means dictionary. You get this as an output. Now, if you add an item to this empty set, you can add an item. Now, if you try printing set, you will get 50 as only item. Now, there is one more way to clear set, which is del statement. But with del statement, your whole object is removed. So with clear, your set is still there. It's just that it does not contain anything. It's now empty. With del, the set itself is gone. If I try to access S after this statement, like if I try to print S or I try to add anything to the S, I will get errors. So del removes the object itself. Same thing happens when you call del on a list. So these are removal functions. Now we are going to talk about other operations. Here are some more operations on set, and these operations are present in other collections as well, like list. So first operation is length. We can find the length of set using length function. So when you call length, it gives you number of items present in the set. Then in operation, which is for checking whether an item is present in the set or not. So 20 is present in the set, we get the output as true. Then when we use this in operator again with 50, we get the output as false because 50 is not present. Please note that in operator is really fast on sets compared to lists, because sets use hashing internally. Here is Python program to demonstrate some operations on two sets. So we have set S1, which represents elements which are smaller than 10 and multiple of 2. Set S2, which represents elements which are smaller than 10 and multiple of 3. So in S1 we have 2, 4, 6, 8. In S2 we have 3, 6, 9. So the first operator is union operator. You must have seen this operator in bitwise OR of two numbers also. But in case of sets, it gives you union of two sets. So what is union of two sets? Say you have a set S1 and then you have a set S2. So there are some elements which are common. So union is going to give you all the elements, common elements also, elements of S1 and S2 also. And common elements are going to appear only once in the output. So everything 2, 4, 6, 8, 3, 6, 9 is going to be part of output. 6 is common, it's going to be there only once. So we get the output as 2, 3, 4, 6, 8, 9. Please note that in Python, this is one way of finding the union. We can also find the union this way, S1 dot union S2 or S2 dot union S1. This is also going to give you union as a result, right? It's going to return you a set which contains union of both the sets. And this union operation does not modify set 1 or set 2. Both sets, they remain as it is. So this is one way of finding the union. This is another way, S1 dot union S2. Let's see the next operation, which is AND operator here. And it was used for bitwise AND of two numbers. Here in the context of sets, it gives you intersection of two sets. So what is intersection of these two? Common elements. And what is common element? 6. Let's see diagrammatically. If you have set S1 and set S2, whatever elements you have in common, that's intersection. So we are going to get the output as 6 only, right? 6 is the only common element. And we can also get intersection by doing S1 dot intersection S2. So it gives you intersection of S1 and S2. You can also call S2 dot intersection S1. And like union, this operation also does not modify S1 or S2. It simply returns you a set which contains the intersection. Let's now see the next operator, which is minus operator, and it gives you difference. So it gives you the elements which are present in S1 and not present in S2. So if you have two sets S1 and S2, what are you going to get in the difference? These elements which are present in S1 and not in S2. So common elements are not there as part of output, and these elements are also not part of output. So what are such elements? You have 2, 4, 8. 6 is not part of output because it's present in S2. So we are going to get 8, 2, 4. Please note that the order is not defined. So we can get these elements in any order in case of sets. So we get these three elements, and we can also get the difference this way, S1 dot difference S2. And please note that S1 dot difference S2 would not be equivalent to S2 dot difference S1, right? Because S2 dot difference S1 will give you the items which are present in S2 but not in S1, right? So S2 dot difference S1 will give you 3 and 9. Let's now see our last operator, which is symmetric difference operator in the context of sets. And when we were talking about bitwise operators for numbers, it was used to give bitwise XOR of two numbers. So what is symmetric difference? If you have set S1 and if you have set S2, symmetric difference is going to give you the elements which are present in both S1 and S2 but not common elements, right? So it's going to give you everything except 6 because 6 is common. And you can get symmetric difference by also calling symmetric difference. Symmetric difference is also a function. So if you call symmetric difference, you are going to get the elements which are present either in S1 or in S2, not in both, right? And you can get the symmetric difference either this way or using bitwise XOR operator, right? We call it symmetric difference operator in the context of sets. And we get the output as 2, 3, 4, 8, 9. Only 6 is absent here. Here are some more operations on two sets. So we have two sets. First set contains all the multiples of 2 smaller than 10. Elements are 2, 4, 6, 8. The other set contains all the multiples of 4 smaller than 10 and elements are 4 and 8. The first operation that we have is disjoint. This operation gives you a Boolean value. It gives you true if there is no common element among the two sets. Otherwise, it gives you false. If you see these two sets, there are two common elements, 4 and 8. That's why you are going to get the output as false. So this print statement is going to give you false. Please note that if you have two sets, 3, 4 and 2, 6, then is disjoint on these two sets would return you true because there is no common element. Now this operator, which is subset operator, right? And we can also replace this operator with is subset method. So you can also call S1 dot is subset, right? And this will give you the same result as this one, this operator, right? This tells you whether S1 is a subset of S2 or not. So S1 is not a subset of S2 because S1 has more elements and S2 has less elements. Now the other operator, which is S1 is smaller than S2, it tells you whether S1 is a proper subset of S2 or not. So what is proper subset? Say if S1 is 2, 4 and S2 is also 2, 4, then this will give you true because they both have the same elements. But proper subset means the elements should not be same. The S1 should have less elements and all the elements of S1 should be present in S2, right? So this condition is true. This condition is checked in both the cases that all the elements of S1 should be present in S2, but this does not allow equal sets also, right? If you have two equal sets, then it's going to give you false. So these both lines in this case are going to give you false because S1 is neither a subset nor a proper subset. Now this operator, which is superset, is S1 a superset of S2, right? And we can also call this as S1 is superset S2, right? When you do this, it's equivalent to doing this. So when you do S1 is superset, it returns you true or gives you true if S1 has all the elements which are present in S2. And since there is an equal sign, if elements are same in both the sets, then also it returns true. So in this case, S1 has 2, 4, 6, 8 and S2 has 4, 8 only. So S1 is a superset of S2, right? So we are going to get the output as true. And this tells you whether S1 is a proper superset of S2 or not. And this is a proper superset of S2 also because it has some extra elements as well, right? 6 is extra, 2 is extra. So it's a proper subset. So we again get the answer as true.